All right. Okay, so next up is lines and angles. So lines and angles problems, most of the time we can solve these with some common sense or just a couple of tips and tricks. These aren't usually too bad. There's a few little tricky problems, and we're actually going to go over the ones that look kind of tricky together, so no big deal. First thing we want to look at, and this is most of the stuff is going to be things that you probably remember from school. First of all, two angles that form a line add up to 180 degrees. Now it doesn't just have to be two angles. It could be a whole bunch or a whole plethora of angles, right? But when we add them all together, we should get 180 degrees, okay? If they form a line, it's 180. Next up, you have vertical angles. Vertical angles are angles that are across from each other. So here, angle A and angle B. Vertical angles are always equal. So angle A would equal angle B. We could also put in angle C on top here. This marker is dying. And angle D on the bottom. And we could say that angle C would be equal to angle D. Okay. Vertical angles are always congruent. Always, 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 always. So always look for those guys. They're going to help you out in a picture. Okay. Next. What else we got? All right, so the sum of the angles in any triangle is 180 degrees. Triangles are your friends. They're going to help you out when it comes to complex pictures. Always look for your triangles. The sum of the angles in any quadrilateral, anything with four sides, okay? It doesn't matter what the shape looks like. If it has four sides, it has 360 degrees, period. That's it. Parallel lines cut by a transversal. Let's talk about that. I need more blank paper. Give me blank paper. That'll work. Okay. So if you have parallel lines cut by a transversal, in school you were taught all kinds of fancy-dancy names to go with that picture, right? Like corresponding angles and alternate interior and blah, 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 blah. We don't need any of that, so don't worry about it. What we do need to look at, make sure I ordered these in the same way. Here's what we need to know about this picture. Okay, first of all, we're going to look at a pair of angles. Let's look at A and B. If you look at A and B, there is an angle that is obviously larger than the other. A is obviously much larger than angle B, right? So for every pair of angles that makes a line, you're going to have one angle that's bigger than the other. So in this picture, we have angle A being a big angle. If we look at angle C and angle D, again, another pair, D is going to be your big angle out of those two. E and F, E is your big, G and H is your big, okay? So the first thing you need to know about this picture is that all your big angles are equal, okay? So all big angles are equal or congruent. That means congruent. We don't need that. We'll just say equal. All big angles are equal, okay? That's the first thing you need to know. Second thing you need to know, and again, just applying a little common sense, if all the big ones are equal, all the little ones are probably equal. So B, C, F, and G. So the second thing you need to know is that all the little angles are also equal. So all your bigs are equal, all your littles are equal, okay? The last thing you need to know about this picture is that any big angle plus any little angle equals, 180 degrees. Okay, any big plus any little equals 180. Those are the three things you need to know about that picture. That's it. You don't care about anything else. So don't make it hard. All right? Any questions on that? Okay. All right, let me erase all that stuff and we'll move down. Okay, so that's what that paragraph right there is telling you. And let's go to number 12. Let's apply this. Okay. Number 12. Note, figure not drawn to scale. Oh, crap. Okay, so let's talk about that. Let's talk about what you can still assume to be true and what is no longer true when your figure is not drawn to scale. If your figure is not drawn to scale, all of your relationships are still true. Okay, that's what you can still say is true. What do we mean by relationships? Your vertical angles are still equal. That's a relationship. I didn't say this angle is 60 degrees. I said that they're equal. Equal is a relationship. Vertical angles are still equal. If you have parallel lines, which we do in this picture, then your bigs are still equal, your littles are still equal. Big plus a little equals 180. Again, those are relationships. I didn't give a value to anything. Okay, I just said how they related to each other. Those are relationships. What I cannot do when my figure's not drawn to scale is I can't use the words look like. So I can't say, ooh, that looks like a right angle, or ooh, that looks like it's 60 degrees. I can't do that. I cannot estimate. Okay? So if your brain goes, well, it looks like it is, figure's not drawn to scale. Can't do that. Make sense? All right, here we go. In the figure to the right, line 2 is parallel to line 3. Up. Which of the following could be false? It could be true, but it could be false. Angle A is equal to angle E. Well, here's A, and here's E. Those are both littles. All littles are equal with parallel lines. So that one is definitely true. So I'm just going to mark them true or false. We know that one's true. B plus E equals 180. Angle B. Angle B up here, well, that's a big. So I got a big and I got a little. Big plus a little is 180. That's true. We know that's true. Line 1 is parallel to line, or perpendicular to line 4. Line 1 is perpendicular to line 4. Let's find those. Here's line 1. So that's this guy. Here's line 4. There's that guy. How do I know that they're perpendicular? What do I know about C and D? I know C and D are equal, which is D. So I know that one's true. Those are vertical angles. But does that make these perpendicular? No. These could be 80 degrees and 80 degrees. They could be 70 and 70. I don't know. The only thing that makes me think that these are perpendicular is because they look like they are. And again, if I'm using the words look like, I can't do it because my figure's not drawn to scale. So the only one that could be false is C. This could be an 89-degree angle. I don't know. It's not marked for me. I'm not told anything about it. Okay. See how that works? All right. Oh, this guy. All right. In the figure to the right, A plus B plus C plus D plus 2E is what? When I first read that question, I said, huh? All right, so we do not have parallel lines, so my bigs plus my littles, all that stuff is off the table. Can't use that. But what shape do you see in this figure? Triangles. Triangles are your friends. Triangles are your friends. Use them to your advantage. But in order to use your triangles, you're going to have to pull these angles in, because I can't use angles that are outside my triangles. So what do we know? If that's angle A, well, that's got to be angle A, right? Vertical angles. So pull them in. Same thing with B. Pull them in. Same thing with E. Pull them up. Okay? Now you have a triangle where you know all your angles. What do you know about the angles of a triangle? They add up to 180 degrees. So let's write it. A plus B plus E has to give me 180. So I've used the top triangle, now let's use the bottom. Pull in C and D. So now on the bottom, you've got another triangle. C plus D plus E has to also give me 180. Think back to your algebra packet. If you have two equations, what do you usually do? You either add them or subtract them, and your answer should pop out at you. So let's try adding. If it doesn't work, we'd subtract. So add A plus B plus C plus D plus 1, 2E equals 180, and 180 is 360. Okay, did I get what I wanted? A plus B plus C plus D plus 2E, I sure did. So it's 360. If that didn't work, I would have tried subtracting. Okay, again, different way of thinking. Got to make your brain work a little differently. Okay, but use those triangles to your advantage. All right. Next up is one that's from your ACT. This should be closer to what you've seen in school in geometry. Again, they're not going to mess with your brain quite as much. All right. So in the figure below, M is perpendicular to line N. Both lines intersect at Q at the same point, which they just tell you that to tell you that. Honestly, that's just, they show you that in the figure. You don't really know that. The measure of angle 1 is 3x minus 10, so we'll put that in. The measure of angle 2 is 2x plus 10. Again, label those diagrams. What is the measure of angle 3? All right, what do we know about angle 1 and angle 2? What do we know about those two guys? They're equal. Yeah, they're vertical, right? They're vertical. Okay, so if they're vertical, set them equal. 2x plus 10 equals 3x minus 10. Now that's going to let me solve for x. Even if I don't know where to go from there, that's at least going to let me get x, and usually solving for x is a good thing. So I'm going to move the x's over, so that's 10 equals x minus 10. Move the 10 over, that's 20 equals x. All right. So if x is 20, I can plug that back in and get these guys, and they better come out to be equal. So if x is 20, that's 2 times 20, that's 40, plus 10, that's 50. So this guy is 50. 3 times 20, that's 60. 60 minus 10 is 50. Awesome, they came out equal. My x is correct. Okay, and then I got to get angle 3. That was my whole goal, was to get the angle 3. Yeah, exactly. There's your line right there. Okay, 180 degrees in a line. So you got 50. They tell you this is the right angle, so you got 50 plus 90 plus your unknown has to give you 180. So 50 plus 90 plus whatever angle 3 is gives you 180, and you can solve for angle 3. So angle 3 should come out to be 40. Ma'am. Right here, there's a little mirror.
Oh, okay, okay.
Yeah. Yes, ma'am. Yes, you can do it that way. Yeah. A lot of times if I skip to that, I lose people, so I just do the 180. All good? All right. SAT number 2 there at the bottom, that's yours for homework. And we're doing parabolas. So parabola problems are only on your SAT. And you're not going to see very many of them at all. So we do this pretty quickly. And we don't have very many example problems because they just don't show up very often. So basic parabola 101, your basic equation of a parabola is this guy right here. Now this is in vertex form. Your vertex is h and k, so you can actually pull your vertex right out of this. However, you're not going to see this very often because the SAT test makers think that this is just too easy. So they're usually going to give you the form of a parabola in your standard form, which is your typical quadratic, your ax squared plus bx plus c. Now, if they give you that form, you can get your vertex using h equals negative b over 2a. Think way back to algebra 1. And then k, to get your k, which is your y-coordinate of your vertex, you simply plug your h back into your function. Okay? So whatever equation they gave you, whatever you get for h, just plug it back in here for x, and you'll be able to get your k. And we're going to do that, not in 36, but in the next problem after that. Your x-intercepts of your vertex, you can get simply by factoring your parabola, setting it equal to 0, and that'll give you your x-intercepts. All right. Number 36. In the graph of the xy plane, the graph of this lovely parabola with b and c, where b and c are constants, has x-intercepts of -2 and -6. What is the value of b? So here they're actually asking you to go backwards. They're giving you the intercepts, and they're saying, hey, give me the parabola. Okay? So before we do it backwards, let's do it forwards. Let's say, different problem, okay? Let's just say that you were given the parabola y equals x squared plus 5x minus 6. Let's say you're given that. And you were told to find the x-intercepts. So you're given the parabola and told to find the intercepts. In other words, the exact opposite of what we did, of what we're being asked to do. So in order to do that, in order to find your intercepts, what I want to do is actually factor this and set it equal to 0. So to factor this, I'd work right to left, factor 6, that's subtract to give me 5. So that's going to be x plus 6 and x minus 1. And then set each one equal to 0. So I get x equals -6 and x equals 1. So those are my intercepts. Okay. Now, in this problem, we're being given the intercepts, we're being given the endpoint, and we're being asked to find the parabola. So we have to work backwards. So our intercepts are -6 and -2. So we're going to take this first step and write our factors. So from an x-intercept of -6, I should get a factor of x plus 6. So from an x-intercept of -6, I should get a factor of x plus 6. All we do is change the sign. Okay? We're going to do the same thing on our -2. From an x-intercept of -2, I should get a factor of x plus 2. Again, we're taking that first step and working backwards. And then to get my parabola, I'm just going to multiply this out. I'm just going to FOIL. So that gives me x squared plus 6x plus 2x plus 12. So x squared plus 8x plus 12. And then I just need to give them whatever letter they wanted. They asked for b. So b is in the middle. So it's 8. So they're asking me for 8. Okay. Questions on that? Okay, next up is a graphing one. Okay, I know that's a little small, but we gotta be able to get all 4 graphs in here, so you got it on your paper in front of you. All right, which of the following could be the graph of this lovely function? So when I look at these 4 graphs, there's 2 things I can look at on a graph that are really gonna help me identify which one it is. One is the y-intercept. Well, when I look at all of these guys, their y-intercept is the same. They all go through 2. So not helpful to me in this case. So I'm not going to waste my time calculating that. The other thing that can help me is the vertex. So the vertex is this low point right here. Those are all in different places. So if I calculate the vertex, I'm going to know which graph this is. Those are the 2 things you want to look for, your y-intercept and your vertex. So let's look for the vertex here. So if you look up above on your paper, how you calculate the vertex when you're given a standard equation is that your h-coordinate or your x-coordinate is -b over 2a. Okay, and your a, b, and c are just like they are for your normal quadratic equation. So that's going to be -2 over 2 times a. A is a ninja 1, hiding next to your x squared. So -2 divided by 2 is -1. So your h or your x-coordinate is -1. So that means it has to be to the left of the axis. My vertex is going to have to be to the left of my y-axis. So I can immediately get rid of c and d because my vertex is on the right. Now, to get your k is f of h. In other words, take that -1 and plug it back in to your equation. So k is going to be -1 squared plus 2 times -1 plus 2. And then just calculate that out. So -1 squared is 1. And then -2 plus 2. So these cancel, so it's just 1. So your k value is 1, which means it has to be up. So I have to be to the left, and I have to be up. So left and up is b. Again, those are kind of the 2 types of parabola equation problems you might encounter on your SAT. ACT, you won't see them. All right. You'll see quadratics on your ACT, but you won't be asked like parabola questions like that. So miscellaneous other graphing questions, these go pretty quick. Lines L and K, we can zoom back in. Lines L and K in the xy plane to the right are graphs of equations in a system. How many solutions does the equation of systems of equation have? Law. So the number of solutions is just the number of intersection points. That's it. So these 2 lines only intersect in 1 point, and it's right there. So there's only 1 solution. Okay, you're just looking for the number of intersections. That's all this. So don't make that difficult. Easy peasy. See, should not have zoomed. Yeah, didn't matter. Okay, number 15. Which of the following is a graph of the system of equations with no solution? So no solution means no intersections. So the one with no intersections is A. Those are parallel lines. Okay. Now let's look at C for a minute. C, you've got two lines that are laying on top of each other. Okay, that's why you have these double arrowheads. That means you have infinite number of intersection points. So this guy actually has infinite solutions. I can't draw an infinity symbol. Infinite solutions. Okay. So the other way they could ask this question is which one has infinite solutions? That would be C. No solutions is A. All right. Triangles. Triangles are your friends. Okay. So a few triangle facts real quick. The angles in a triangle have a sum of 180 degrees, which we've already talked about. Your area of your triangle is 1/2 base times height. Pythagorean theorem. Most of you guys have seen this one too. So Pythagorean theorem is a squared plus b squared equals c squared. We're going to apply that to right triangles. So right triangles, to make sure your c squared is your hypotenuse. It's the long side that's across from your right angle. Make sure you get the c right. The a and the b don't matter. Okay. This can only be applied to right triangles. Well, you think it can only be applied to right triangles. We're going to break that rule in a little while. Right triangles, you do have two special cases of right triangles. You have a 45-45-90 and a 30-60-90. These two guys are on your formula sheet for your SAT. Again, your ACT, you don't get one. So the way your 45-45-90 works is you have two sides that are equal length, A and A, and then your hypotenuse is A times root 2. Okay? Your 30-60-90, your little guy A is across from your 30-degree angle. So across from the 30 is your little guy A. Your hypotenuse is 2 times the little guy. And that leaves your third side to be the ugly A root 3. Okay? I'm going to say it to you that way over and over and over, and hopefully that'll help it stick in your brain. I will show you an easy way to apply these when we get to those problems. We have 3 different types of triangles. We have equilateral, isosceles, and scalene. Equilateral, what it means is right there in its name. They are equal. It's just spelled weird. So in an equilateral triangle, you have 3 equal sides and 3 equal angles. All your angles are 60 degrees, and all your sides are the same. They are whatever they are. In an isosceles triangle, you have 2 equal sides and 2 equal angles. Don't forget about the equal angles. Okay? In a scalene triangle, everybody is different. Everybody's unique. All right, next page. Third side rule. So the test makers call this an obscure rule. Apparently they don't know the definition of the word obscure. So obscure means it doesn't come up very often, and this rule shows up all the time. So this rule basically says that if you add up the 2 sides, the 2 smaller sides of a triangle, it has to be bigger than the third. If it's not, it won't actually form a triangle if you were to draw it to scale. Okay, so that's the way that rule works. We'll have an example of that in a minute. Triangle tip, the longest side of a triangle is always across from your largest angle, and the shortest side is always across from your smallest angle. It can help you when you're drawing them out. Acute versus right versus obtuse. This is where we kind of break the Pythagorean theorem. So you know the last one. You know if c squared is equal to a squared plus b squared, then your triangle is a right triangle. That's Pythagorean theorem. Okay? But we can also use the Pythagorean theorem to tell us whether a triangle is acute or obtuse. Okay? So, but we have to do that. To do that, we really need to look at it from C's perspective. So we're going to put C first. If c squared is less than a squared plus b squared, then you have an acute triangle. If c squared is greater than a squared plus b squared, then you have an obtuse triangle. Okay. And again, we'll have an example of this in a minute. So Pythagoras is very helpful for being very, very dead. All right. That's better. All right, number 54. Which of the following list of numbers could be the side lengths in inches of a triangle? So this is that obscure rule that isn't very obscure. Add your 2 smaller sides together. It's got to be bigger than the third. Can't be equal. It's got to be bigger. 1 plus 2, that's 3. That's not bigger than 3. A is out. 2 plus 5 is 7. It's not bigger than 7. It's out. 3 plus 7 is 10. That's smaller than 11. That's out. 4 plus 9 is 13. Not bigger than 16. 5 and 8 is 13. Aha, that's bigger than 10. That works. That's how that rule works. Okay? It's not hard to apply. Just don't think too hard about it. Okay, 48. The side lengths of a certain triangle are 4, 5, and 7, which is probably best classifies this triangle. So we have 4, 5, and 7. We have 3 different numbers. So let's look at the first word. Is it scalene or is it isosceles? What is it? It's got to be scalene. They're all different. If they're all different, it's got to be scalene. It can't be isosceles. Isosceles would have 2 equal numbers. So it's either scalene acute, scalene right, or scalene obtuse. So to figure out whether it's right, acute, or obtuse, we got to apply the Pythagorean theorem. So A, B, and C. My big number has to be C. The other two, it doesn't matter which one's A and which one's B. I'm just going to take them as they come. I'm going to say A is 4 and B is 5. So I'm going to set this up. I'm going to have C squared, and I don't know if it's less than, greater than, or equal to, so I'm just going to put a question mark. And then A squared plus B squared. So 7 squared is somehow related to 4 squared plus 5 squared. So if we calculate that out, that's 49. This side's 41. So 49 is greater than 41. So if it's greater than, that means it's obtuse. So scalene, obtuse. Okay. Any questions on that booger? All right. Go from nice, straightforward calculations to make my brain work. Okay. SAT number 17, in triangle XYZ below, what is the value of B in terms of A? How many triangles are in this picture? It's better. 4. Actually 5, but we'll take 4. Yeah. So, let's think about that. There's at least 4, but let's go with 4. 4 triangles in this picture, okay? I want to use the triangle that I know the most about. By know the most about, I mean which one does not have any blanks in its angles. I don't care if it has letters. I don't want blanks. So which triangle has no blanks in its angles? XYZ, the big one. The big triangle, the outside triangle, is the one that doesn't have any blanks in its angles. That's the triangle I want to use to solve this problem. So in triangle XYZ below, what is the value of B in terms of A? I'm going to use the big guy. So XYZ, I know that when I add up the angles of my triangle, I should get 180. So angle X is A plus 30. Angle Y is A plus 20. Angle Z is B. And that should give me 180 degrees. Okay? And all they want is angle B in terms of A. So all I have to do is actually solve this for B. So I've got 2A, I've got 50 plus B equals 180. I'm just going to isolate B. So I'm going to move the 2A and the 50 to the other side. So B equals 180 minus 50 is 130. And then I'm going to subtract 2A. So 130 minus 2A, D. Okay. Always look for the shape that you know the most about. All right, ACT number 6. In triangle ACD to the right, B is on AC, E is on AD, and the measuring angle CAD is 28, AD is perpendicular to both BE and CD, which is all marked for you on the figure. This is an ACT problem. The information is going to be in the figure. What is the measure of CBE? In other words, find the question mark. I don't even really need the question. Everything's here. Okay, so locate question mark. Got it. So I can't find that guy directly. Again, I'm going to look for triangles. I'm going to ignore this side of the shape. I'm just going to look at this guy. Right here. All right, so I'm going to look for that angle right there. I'm going to find that guy. So to get that guy, I'm going to do 90 minus 28. And that should give me that angle. So 90 minus 28 is 62. And then I know these two angles, 62 and my question mark, should give me 180. Thank you. I'm like, my mental math is failing there. So that should be 118 degrees for my question mark. Okay, again, use your triangles to help you. All right, that's it for that dude. On to some 30, 60, 90s. All right, in the triangle to the right, x is 60. What is the length of AB? Okay, so now we're getting into the 30, 60, 90 stuff. The easiest way I have found to apply these triangles works like this. Draw your pattern triangle next to your picture in the same orientation as your picture. So the 30 is in the bottom left, the 60 is in the upper right. Okay. Now, across from the 30 is your little guy A. Across from your right angle is 2 times the little guy, which leaves your third side to be the ugly A root 3. Okay. Once you have your pattern triangle drawn, match up your sides and find A. Okay. So match up your sides. You have a vertical side here and a vertical side here. So A is going to be 4. Okay. So if A is 4, 2A would be 2 times 4 is going to be 8. A times root 3 is just 4 times root 3. Okay. And then the hard part's done. Then you just go back and give them whatever they wanted. In this case, they wanted the side AB, which is 2 times A, which is 8. So my answer here is just 8. Any questions on how to apply that? Okay. All right, we're going to do it again. Next problem. In triangle ABC, which is not shown, angle ABC is 60 degrees and AC is perpendicular to BC. If AB is x, then what is the measure of, what is the area of ABC in terms of x? Okay, so we have triangle ABC. And we know there's a 60-degree angle involved, so we know we're going to need our pattern triangle. So might as well draw him out real quick. Okay, so AC is perpendicular to BC. I need to get my letters in the right places, and I'm going to use that perpendicular statement to do it. I look for the letter that repeats itself. C repeats itself here and here. Okay? So the letter that repeats itself is my right angle. So that tells me that C is this corner. And then again, A and B, it doesn't matter which one I put where. So I'm just going to put A in the bottom left and B in the upper right, but I could reverse that. Okay. Angle ABC is 60. So the angle in the middle, B, is what, 60? Which means this guy is 30. Okay, so I'm going to draw my pattern triangle in the same orientation. 30 degrees down here, 60 degrees up there. Across from the 30 is my little guy A. My hypotenuse is 2 times the little guy, which leaves the third side to be the ugly A root 3. All right. They also tell me that AB is equal to x. I have letters in my answers. What do I do with letters in my answers? Plug in a number. Okay, I'm going to tell you that you want to pick an even number in this problem, unless you really love fractions. What number would you like to pick for this problem? I mean, even number. 4. 4 sounds good. X is 4. I'm also going to write this over here because I have a habit of forgetting what I've chosen for x. Okay, so x is 4. My goal is to get the area. Well, to get the area, I'm going to need these two sides. So let's work on finding that. All right, so I've got my pattern triangle all set up. I just need to match up my sides and find A. So match up my sides. 2A is going to be equal to 4. That makes A equal to 2. This is a non-calculator problem. A is 2. That makes this side 2 root 3. Okay? No, because x is 4. This whole side is 4. So if you match up your sides, yeah. A isn't 4. 2A is 4. Yeah. Hard part's done. You got your triangle. Go back and give them what they wanted. They wanted area. Area of a triangle is 1/2 base times height. Those are always the two sides that form your right angle, so it's this guy and that guy. So 1/2 2 times 2 root 3. 1/2 and your 2 are going to cancel out. Your area is 2 root 3. So that's your goal. You're shooting for 2 root 3. If you plug in 4 to your answers, the only one that's going to give you 2 root 3 is going to be A. That's 16 over 8. 16 over 8 is 2. That's how we do that. Fun times, people. Fun times. Okay. SAT number 10. In the figure to the right, segments AE and BD are parallel. If BDC measures 58 degrees, BDC over here, 58 degrees. ACE, the top, measures 62. What's CAE, bottom left? So again, I can't get this directly. But the angle I can find is this one here. That's part of that little triangle at the top. So let's go ahead and find him. So if I add these together and subtract from 180, I believe I get 60 degrees. Okay. And then I have parallel lines. Anytime you have parallel lines in a picture, extend them out. And extend out your transversal. That will help your eyeballs see what's going on in your picture. So if I look at these guys, these are both littles. All littles are equal, so my question mark has to be equal to my 60 degrees. Okay. That's how we tackle that. All right, next couple problems are about proportional triangles or similar triangles. In the figure shown below, E and G lie on AC, D and F lie on AB, DE and FG are parallel to BC, and the given lengths are in feet, not that we care about the units. What is the length of AC in feet? Okay, so the only thing they really didn't mark for us was that these are parallel, and that you're looking for this whole thing. Okay, so what we know about this picture is that because these are parallel, that makes every single triangle here, and you've got 3 of them, similar triangles. So for similar triangles, you know their sides are in proportion. That also means that their parts are in proportion. So to go from 6 to 12, you multiply by 2. So to go from 5 to EG, you're also going to multiply by 2. To go from 4 to GC, you multiply by 2. And then to get the whole thing, we just add. So 12 plus 10 plus 8 is 30. So your answer would be D. No, the segments are not. However, your segments will be in proportion as well because all of these are parallel. Okay. You do have 3 triangles. They're just hidden in here. So if your triangles are proportional, your segments are proportional. Okay. 23 is yours to do for homework. And number 6 at the bottom is yours to try. And then we'll pick up with these ugly hexagon problems next time. All right, guys. Next week, make sure if you own a graphing calculator, make sure you have it with you. I'm going to show you some tricks. No problem.